Welcome to my podcast on solving separable differential equations. As you remember, a separable differential equation is an equation that allows us to separate the variables on either side of the equation, making it easier to solve these. The equation we're going to look at is dy over dx equals e raised to the x minus y power. Now we have an initial value condition that I will mention later. But for now, we're going to go ahead and go through the process of separating the variables. So one thing to remember is your properties of exponents. So this could be rewritten as dy over dx equals e to the x over e to the y. Now you can see we just get e to the y dy equaling e to the x dx. And suddenly the problem looks pretty simple because, as I've said, when the variables are separated, it's time to integrate. And so with this integration, we get e to the y equaling e to the x plus c. I like to do these problems in columns, as I've always told my students there are kind of 3 steps to these problems, or 3 parts. And so we've done the first part, which is to separate the variables and to find a general solution to the problem. But we by no means are finished. Now our initial value condition is when x is 0, y should be equal to 2. Well, it would be nice to solve for c now if it was possible, but we very well might get an irrational value. And so sometimes with these exponential functions, waiting and solving for c towards the end might be an easier path. So what we'll do now is we'll go ahead and try to solve for y by using some other algebra. And in this case, taking the natural log of both sides is a good choice. Need to make a little more room here. And so that gives me that y is going to equal the natural log of e to the x plus c. Now at this point, I'm going to go ahead and try to solve for c by using the initial value. So I want 2 to equal the natural log of e to the 0 power plus c. So if I decide to make both sides into a power of e, you can see what I get is e squared equals e raised to the natural log of 1 plus c. But e raised to the natural log of 1 plus c is just 1 plus c. And so c must equal e squared minus 1. Which makes our final solution to the problem y equals ln e to the x plus e squared minus 1.